Some more examples just like the ones on your chapter test. So we have absolute value of negative 3x plus 7 is less than 2. So less than 2, we would apply rule number 1. The rule says that what's in here, the value negative 3x plus 7 lies between negative 2 and positive 2. Next, we solve for x. We subtract 7 throughout. The direction of the inequality doesn't change, it remains as less than. So negative 9 less than the positive 7 and negative 7, that makes it 0. So that's negative 3x is less than negative 5. Now we have to solve for x, which means we need to divide throughout, and the important thing here is it's a negative number that we're going to divide by. And remember the important rule. What happens when you divide or multiply with a negative number is the direction of the inequality is going to change. So negative 9 over negative 3, negative 3x over negative 3, negative 5 over negative 3. But what's important here is the less than becomes greater than. The direction of the inequality changes because we've divided throughout by a negative number. So this becomes a positive 3 greater than the negative 3, and the negative 3 becomes a 1. 1 times x is greater than 5/3. The negative signs get cancelled. So this is the inequality. We could write this as 5/3 is less than x is less than 3. So if you have 5/3 here, 5/3 is less than 3. These two mean the same thing. This means that x lies between 5/3 and 3. The smaller number always comes on the left and the larger number on the right. We don't include the endpoints. And everything in between is included. Now we have another absolute value inequality. Oh, let me just finish this. This could also be written as 5/3, 3. This is the interval notation. The smaller number is the lower limit, the larger number, which is 3, is the upper limit. Everything in between counts. So we have, remember that we have to first solve for the absolute value term, which means we need to subtract 1 on both sides. So absolute value of negative 4x plus 2 is greater than 7 minus 1, which is 6. Now, what applies here is rule number 2, because we have a greater than. If it's less than, it's rule number 1. If it's greater than, it's rule number 2. So this, we can break this down into two inequalities. The quantity negative 4x plus 2 is less than negative 6, or the quantity negative 4x plus 2 is greater than 6. Now each inequality has to be solved. We subtract 2 on both sides. Remember, we want to get rid of everything except x. So negative 4x is less than negative 6 minus 2 is negative 8. Now remember, we have to get rid of negative 4. We need to divide both sides by negative 4. It's a negative number, and that's important. Something different happens here. The inequality gets switched when you divide both sides by a negative number. So negative 8 over negative 4. So that would give you x greater than 4 goes 2 times into 8, the negatives cancel, and x is greater than 2. Let's solve the other inequality. 4x plus 2 is greater than 6. Subtract 2 from both sides, and we have negative 4x is greater than 6 minus 2, which is 4. But we have to divide both sides by a negative number. Again, don't forget the important step here. The inequality gets flipped in the opposite direction. And we have 4 over negative 4. Remember that both sides we're going to divide by negative 4. So this becomes an x less than negative 1. So x is either less than negative 1. So let's look at what that looks like. So x is either less than negative 1. So any number less than negative 1 goes on forever here on the left. It's a strict inequality, so there's a hole. And then if this is a 2, make a hole there, and x greater than 2 is everything to the right of 2. So negative infinity to negative 1 always go in order from left to right. Union, leave the 2 alone, don't include it, but then everything to the right of 2 is included. So that's the solution to the inequality. Let's do one more. Remember, the first thing is to solve for the absolute value term. So we subtract 1/3 from both sides. Subtracting the exact same number from both the sides does not change the direction of the inequality. So that's 3x minus 2, absolute value of 3x minus 2. That's a 0. So when you add 0, it's just absolute value of 3x minus 2. 2/3 minus 1/3 is 1/3. Now, since it's a less than or equal to, we're going to use rule number 1. And the rule says whatever is inside 3x minus 2 has to lie between two numbers. One is the negative of 1/3 on the left because it's the smaller number, and positive 1/3 on the right. So we're trying to solve for 3x or x. That's our goal, but we're going to solve for 3x first by adding 2 throughout. Adding the same number does not change the inequality. So negative 1/3 plus 2 is less than or equal to 3x is less than or equal to 1/3 plus 2. Let's simplify this expression. I'm going to take a common denominator, negative 1/3 plus 2 over 1. So I multiply the denominator by 3 and the numerator by 3, or use your calculator. Is less than or equal to 1/3 plus 2 over 1. I multiply the denominator by 3 and the numerator by 3. So we have negative 1/3 plus 6/3 is less than or equal to 3x is less than or equal to, and remember you can use your calculators for this. So that's 6/3 Common denominator of 3, 6 minus 1 is 5, less than or equal to 3x is less than or equal to common denominator of 3, 6 plus 1 is 7. Now divide throughout by 3. So we have 5 over 3 times 3. It's a positive number. Remember that if you're dividing, it has to be in the denominator in all the fractions. So you multiply the denominator by 3 is the same as dividing the entire number by 3. So that's 3x over 3 is less than or equal to 7 over 3 times 3. Finally, we have x in the middle, less than or equal to 5/9 less than or equal to 7/9. 5/9 is less than 7/9. And if you had to graph this, let's say that's 5/9. And that is 7/9. The endpoints are included. And everything in between is also included. So it is the closed interval. Remember that the endpoints are included. So it's 5/9, comma, 7/9, close parentheses. So this would be the square brackets because of the inclusion less than or equal to.